Hey, let's talk about scaling web applications, more specifically scaling serverful web applications. We're going to deal with VPSs and dedicated servers. We're not going to deal with lambdas and cloud containers. Okay, so this is how this video is going to go. We are going to define a timeline of scaling an application, starting from the very beginning where we don't have any users and we are starting super small, which is also super cheap. And then we're going to progress and scale our application based on the traffic and other factors. So we're going to start with that. We're going to discuss about the two types of scaling, which are vertical and horizontal, and when to use each of them. And then we are going to literally deploy a Laravel application that uses Postgres as a database and Redis for caching to a VPS server using a tool that is really freaking cool. Okay, so if you're ready, I'm ready. Let's dive in. Before we dive in, I want to say a quick word for the sponsor of this video, Ultahosts. They reached out to me at the right time, just when I was working on this video, so the pieces kind of fit together. Ultahost is a web hosting company, so they offer shared hosting, they offer VPS hosting, dedicated servers, and even some Windows and Mac servers if you're deploying something specific to the operating system. You can check out their website to see their full offering. But what caught my eye is their Ulta AI Assistant. They have this nifty tool on their website that lets you explain your situation to them, what is your website and how many monthly active users you have, and it can prepare the right plan. For example, I asked it I have a Laravel and React application with 300,000 monthly active users. Which servers do you recommend me to buy? And it recommended me to get the Power Premium or the Power Ultra, etc. So yeah, pretty cool stuff. Thanks again to Ultahost for sponsoring this video, and now let's get back to it. Let's start with the very beginning. You have no users, but you have an MVP version of your application. You already have an application and you are ready to deploy it. So you get one VPS server, for example, US East small, which is like a small label of a server. These are very cheap, but they get the job done. So you deploy it on US East SM, whichever you know, and like you have just have one server, you can have Git in there and then just Git pull and then start the application. That's gonna work, right? You have no infrastructure to manage. So if that does it, that does it, right? But then your users are starting to grow, right? So your server load is gonna increase and you're gonna end up in the red zone. And of course, this is where you want to do some scaling. So what do you do? I guess the most straightforward approach would be to buy a new server, which is more expensive. So for example, let's get US East large, right? And let's put the progress bar to the US East large. And of course, this is going to be, it's not going to be high traffic or high load like the smaller server, but it's going to be something like that. So when you buy a server, you're going to get an IP address. So what you do is in your DNS settings on your domain, you're just going to change the IP address of your domain so it points to this server, right? The moment you do that, all the traffic from instead of going to the old small server, it's going to go to the new large server. And let's say you already took care of migrating all the data and setting up the database. Everything is ready, right? And you can just simply delete this one. Great. So now you have successfully vertically scaled your application. So from using a small server, you have a large server now. Of course, size doesn't matter like a physical size, but in terms of performance and RAM and CPU and all the other factors. So now this one can take much higher load, much higher traffic. But Yeah, as I mentioned, this is vertical scaling. And how far can you go? Let's say that you can do this like 2 or 3 more times and you end up to something like 4 extra large, a server that is 4 extra large. And at this moment, you hit the first con, okay? Yeah, let's actually do some pros and cons. So for the pros of vertical scaling, one would be simplicity, because you don't have an infrastructure to manage. Everything is on one server. You don't need Docker. You don't need anything. You have just one server, which is a computer somewhere in this world connected to the internet. You SSH to it. You pull your web application there, and it's running. Great. It's simple, right? And also, it is cheap, but at the beginning. Okay, it's simple and cheap, those two things. But the moment when you reach, I don't know, 4XL, whatever that means, you get what I'm saying. The moment you reach that, you start to hit on the first con, which is going to be it gets exponentially expensive when you go into those higher tier specialty machines. Okay, they get like exponentially more expensive. So your scaling is kind of limited, right? The most you can go is, I don't know, whatever is commodity hardware for the hosting provider that you're using, right? At some point, it becomes like specialty hardware, and it becomes way too expensive for you to justify. Okay. Another issue is that your single server is in a single location. As you can see, we have US East for Excel, right? That means it's in the United States on the East Coast, somewhere on the East Coast. So that means you are geo-locked, right? If you have an even distribution of users across the continents, then they're all going to make the trip to the USA and back in order to render their website. So you are geo-locked, and there are situations, depending on the nature of your application, where this can really matter. Okay, so pros. It's simple. It's just a single machine. Set it and forget it, right? And it's also cheap at the beginning. This is cheap scaling at the beginning. You can just jump, one scale larger, right? And that's gonna work for you. But yeah, cons, exponentially expensive when you get to the high tier specialty machines, and you're also geo-locked. So let's say that you reach that level. What do you do? Well, that's when you start doing horizontal scaling, which is not redeploying your application on more powerful servers. It is redeploying your or deploying your application on multiple servers. Okay, so let's look into that scenario, which is going to be the horizontal scaling. Okay, let's say that we are going to scale down instead of keeping at 4XL, because these are expensive, right? We don't need to, because we're going to be buying more of these. We can scale back to US East large, right? So here's one, and we can buy 3 more of these servers, right? So 3 large servers in parallel. Let's say that they can compete with the 4XL, even though it's 4. We have parallelism now, right? That's points for performance. But in this case, we have 3 separate IP addresses. This one lives on one IP, this one lives on another, this one lives on a third IP, right? And this is where we hit the first con, which is going to be, I'm going to start with the cons now, which is going to be not so simple, right? We have multiple servers, and we need to figure out how we are going to hook all of them up. And luckily, this is not rocket science. There are ways to do this, and the most straightforward way, which I believe is like 99% of the cases, is to use a load balancer. So I'm going to bring in an icon that says load balancer, something like this. And what the load balancer is it is a server by itself. So it's a server just like the 3 that we have here. It does have its own IP address, but the idea is that we are going to task the load balancer only with the job of routing the requests. It's not going to do any CPU intensive processing. It's not going to dip into the database or whatever, doing some synchronous or asynchronous processes. No, it's just going to be a traffic controller. Okay, hence the icon. Right, so this is going to be the load balancer. It's a server, so we get an IP address. That means our DNS settings can point to that IP address now instead of the one server or any of the servers that we have in this case. And now we're going to configure the load balancer to point or to route all of the requests that are coming in to any of these servers. And it's going to know where they are because we're going to give the load balancer the IP addresses of our servers. So requests are coming in, and there are multiple algorithms depending on which load balancer or proxy software you pick. But for example, there can be, usually it's round robin. What does that mean? We have one request coming in, it's going to go to this server. Then we have a second request coming in. Well, the second one is going to go on the second server. And then we have another, it's going to be on the third one. So you see, it's a round robin, right? That's the algorithm, the most common one. That doesn't really matter in this case. In this case, we solved the first con, right? It is not so simple, of course. It still is not so simple, but we kind of solved it. But that unlocked pros. That unlocked something for us. That unlocked a really cool pro, which is called technically, I'm going to say technically, in parentheses, unlimited scaling. All right, we mentioned that in vertical scaling, we had somewhat limited, and we didn't actually write it down, but like limited scaling in vertical, because we can't go more powerful. Eventually we'll hit, what if we find the most powerful server on this planet and we're going to buy that one, money is not a problem, and then what, right? So your scaling is limited, and that's a big con for vertical scaling. But in this case, I'm going to say technically unlimited, because it is unlimited because we can keep adding, like US East largest, or we can even get some servers in Germany, some servers in Asia, so we can cater to those users. We can just attach servers to our load balancer network, and there we go. We are scaling seemingly unlimited. Of course, there are limits. There are limits to everything, right? So this is another way that you can scale your web application as your traffic or user base grows. And usually in real life, it is a mixture of both. I mentioned geolocking, I mentioned users living in specific areas of this world, and I also mentioned having the need to have multiple servers to, handle things in parallel, handle the requests in parallel. So the question now that you get is, let's say that we have 15 US East large, or 15 large servers just sprinkled all across this world, right? Some in North America, some in Europe, some in Asia, wherever. How do I deploy my application on all 10 or 15 of them? Do I SSH into all of them one by one and deploy my application? No. If you're doing that, please stop doing that. There are much better ways. And we are going to discuss one now, which is using Docker to containerize our application, build it for a specific specific server architecture, for example, like ARM64, and then we're going to take that image and just spread it across all of these servers. And we don't want to do the spreading manually. We're going to do the spreading automatically using Kamal. Okay, so Kamal is an open source tool built by 37 Signals. It allows you to have a network of VPSs or dedicated servers like the one that we described now, and automatically deploy your application to all of them and even roll back. Okay, so it's really cool, and this tool solves a lot of the complexity around scaling web applications on or horizontally scaling web applications on multiple servers. Okay, so we are going to take the Laravel React starter kit, that is Laravel and React. It also includes Postgres as a database and also includes Redis for cache. And we're going to deploy that on a VPS. So let's check it out. In order to install Kamal, you need to run gem install Kamal. It's a Ruby gem, so you need to install that gem, and you can run Kamal init at the root of your project to set up Kamal or generate the configuration files that you need to deploy your whole application. So I already did that in my application. We're not going to be writing code. We're just going to be showing or exploring code. Okay, so when you run Kamal init, it's going to generate two things. First, it's going to generate a deploy.yaml file inside of the config at the root of your project. And then it's also going to generate a .kamal directory with a bunch of hooks that lets you do stuff depending on when the hook is, and also a secrets file where you define all the environment variables, all your API keys and secrets and stuff like that. So here's the project. Nothing fancy. As I mentioned, it is literally just the demo project that you can download from Laravel's website. And now let's get into the deploy.yaml file, because this is the first one. Okay, so at the top, you define your service name. And this does nothing. It's just going to label all of your containers with your service name, right? If this is a full stack application, it's going to be like, I don't know, my app or Nicole of Lazar, because that would be my website, right? That's all. This also tells you that we are deploying a single service, right? This is the name of the service. So if you have multiple services, if you have a service-based backend architecture, you're going to have Kamal init and Kamal config files for all of your services, but it's still going to work, okay? So yeah, this is a full stack application, just a single service, and it's called my app. I'm lazy. I'm going to keep it to my app. And then we have the name of the container image that's going to get generated from our project. So I'm tagging my username, which is my Docker Hub username on the container registry /deploy with Kamal. Let's go with that, right? And I need this because Kamal is going to build my application and your application and everyone's application and upload it to whatever container registry we tell it to. So by default, it's going to be the Docker Hub, the Docker container registry. But you can upload it to DigitalOcean's registry, to GitHub's container registry, etc. We'll get to this section and we'll talk more about that. But yeah, this is the image, and because we're uploading on Docker Hub, this is my username, okay? And then we have the servers section. This is how we tell Kamal to deploy to these servers, all right? This is an IP address that's not going to be available like after this video, because I'm just going to scrape this server, but this is the IP address of my VPS server. I just bought it. It has nothing on it, and I'll prove it to you. It doesn't even have Docker, but I added here. If I have multiple servers, then I'm just going to add all of their IP addresses here. And what Kamal is going to do, it's going to SSH in all of these and then just deploy my application to all of these. So that's what I'm saying. You don't do anything by hand these days, okay? this is how we define our network of servers. And Kamal doesn't care about the provider. It doesn't care about anything. It just cares about the IP addresses and whether it has SSH or not. So you only need to make sure that Kamal can access the server through SSH. That's all, okay? I'm not gonna touch on jobs in this video, but we can talk about it in my Discord, and you can check it out. You can go to creatures.sh and send me a question if you have any. Okay, next section is the proxy. And this is basically Kamal's proxy, which is basically Nginx. Okay, this way we automate even the proxying to this server, right? So we want to use SSL. This is going to be the URL that we're going to access this application from. So deploy with kamal.nikoloflazar.com. And the app is going to be on port 8080. So what Kamal is going to do is going to register the 80 port and the 443 ports for HTTP and HTTPS, and it's going to route them to the 8080 port, which is internal, which is going to be the port that the Docker container exposes and it serves our app from. And this is just a general health check that Kamal uses to make sure that the app is up and running. And the /app is a Laravel built-in health check. Doesn't matter, you can just define a custom endpoint, and there we go. It's nothing complicated. All right, then we have the registry, as I mentioned. By default, it's going to be the Docker Hub. But if you are using, for example, GitHub or some other registry, this is where you define the server. And you will uncomment this line and write the server of your registry. And then you are going to add your username and password. Now, these are secrets, okay? And these will get pulled from the secrets file I mentioned briefly earlier, the .kamal/secrets. We're gonna get into that, but for now, just know that there's a secrets file and the Kamal registry username and password are defined in that file, okay? That's all. Next, we have the builder section, which tells Kamal what is the architecture that it needs to build the image for, what is the context, or like where is the project that we're building. We can separate these, the configuration for Kamal and also the project itself. Maybe we have a mono repo. You can change the context and also point it to the Docker file. And yeah, I have the Docker file right here. It's at the root of the project. I can open it, but it's not going to matter in this case because we're not talking about how to Dockerize a Laravel application. And I might not even be doing this right. So we're not going to talk about that. The next one is cache. And this is the build cache. So I'm using the registry cache. That means it's going to push another image, which I believe it's an image, another image, or create another repository in my Docker container registry, and it's going to keep the build cache over there, right? And the mode is set to max. So if I don't change anything in my project, and if I run the Kamal deploy application to deploy my application, I'm not actually going to rebuild the whole image from scratch. I'm going to reuse a bunch of the layers because they're already built. There are no changes in those layers, so I'm just going to reuse the cache. You definitely don't want this at the very beginning because you might not get things from the first try. Kudos to you if you do, but comment this out. Start without cache. Make sure that your Docker pipeline is properly set up and then get the cache rolling, okay? And we can this way we can also add any build arguments that we need for our Docker file this way. And of course, they can be pulled from the secrets as well. All right. Next, we have the environment section. And there are two parts of this section. We have the clear and the secret. The clear section basically defines hard-coded values, which are clear. Imagine we are pushing all of this to the repo. This could even be an open source project. So the clear environment variables are going to be the ones that are not so secret. For example, the app URL, of course, our users and everyone will know that this is the URL. The environment is always production because we're deploying on production. The application name is not changing. It's not a secret, etc. And it's safe to say that the DB host is going to be DB in this case. And this is an alias. It's not a literal string D and B, but it's an alias to another container running that is set up by Kamal. We'll talk about that in a bit below. So DB, another container that runs our Postgres database, point to that one, whatever its address is. Same for the Redis, okay? And these are just strings. And then we have the secrets, and these are pulled from the secrets file that we're gonna look into shortly. And that's about it. This is how we define the environment. We have aliases. I don't have aliases enabled, but instead of typing all of this, Kamal app execute interactive reuse bash, you can just say shell. So you can run Kamal shell into the terminal, and this is going to get executed. Simple. This is how you define aliases. By default, it uses the root SSH user, but in this case, on my server, I created a Lazar-Kamal user. It's not going to be root, so I'm just telling Kamal to use that user or SSH as Lazar-Kamal. So what Kamal is going to do is going to do SSH, and let's actually do that right now. We're going to pretend that we are Kamal. So I'm going to copy the IP address here, and I'm going to do SSH Lazar-Kamal, because I told it that this is going to be the username, not the root. And then I'm just going to paste the IP address. And if I hit enter, it's not the first time that I'm getting into this server, but there we go. We are in the server, and I can get in because my SSH key is added to this server. And yeah, we're in the server now. So if I do pwd, we can see that we're in home Lazar-Kamal. If I do who am I, I'm Lazar-Kamal. And if I do docker, we're going to say command docker not found. So this is literally a blank Ubuntu 24.04 server with nothing on it, not even Ubuntu. So I'm just going to get out. We don't need to be inside, and proceed with the configuration, right? So SSH, that's about it. If we have volumes, and you should have separate volumes that are attached to your VPS, don't put your database on the same VPS as your application, because, let me actually make this tangent because it's really important. Because if you vertically scale, that means you're going to need to copy the whole database and migrate everything to the new server. As opposed to if you have a volume attached, then you can share that volume with the two servers. So you're not going to do any migrations because it's already been done. And also in this case, it's not going to be possible because if you put the database in this server, then how are these servers going to access it? Not possible, right? So we need a database here. And I'm going to put a little database here, which is going to be a shared volume or volumes. And all of these servers are going to be using it. All right. So that's what you should do. And you're going to mount that volume to each of these servers. There are tools that let you automate all of this, so you don't have to do this by hand. But this, when you mount the volume, it's going to be somewhere on your local path inside of the, this is going to, on the left side, is going to be inside of your machine. So /mnt/, usually it's like the web storage or something like that. Let's actually check. I'm going to go back to my server and let's do cd /mnt/. Oh, there's actually nothing here because we don't have any, we're not using anything right now, but we will. Okay, later I can, if I remember, I'll circle back and I'll show you. But yeah, when you mount volumes, they appear in the /mnt/something, the name of the volume. So this is how you would map this, all right? This is how you would map the inside of the container and then on your VPS or server path. That's about it. If you have fingerprinted assets, if you're not using a CDN, you can define these assets path. And I don't know that much about this. So if anyone knows, drop a comment under this video to tell us about the assets path, because I still haven't used this. Okay. There's a rolling deploy option that we can set a wait time between the batches of restarts. For example, we're going to limit 10 batches of restarts, and there's going to be 2 seconds of wait time between them. So if we have 30 servers, it's going to be 3 batches of 10 servers. We're going to restart the first 10, and we're going to wait for 2 seconds, and then restart the first 10, wait for 2 seconds, and then restart the second 10, and so on. So that's the rolling deploys thingy. And then lastly, because this is the end of the file, we have the accessories. And the accessories are also services, okay? If you want to see a correlation between Kamal and Docker Compose, let me actually open the Compose YAML file, and I'll show you. The main service, which I don't have here, is your application. And then the accessories are basically these services in your Docker Compose. So DB and Redis, that's what I'm using as like third-party services, and I'm actually defining them as accessories in Redis. So the first one is going to be the Postgres 17. We're going to use that image. This is the host where we are deploying. So you see we can actually put the any accessory to other servers or hosts, not on the same one, so we can define that. In this case, I have the same IP address, but if you have a different server with more hard drive or more SSD or more storage in general than the other ones, then you're going to deploy it to that host, for example. I don't know. This lets you define your infrastructure the way that you like. And it's going to be the DB service. The name of the service is going to be DB. And then that's also how we know and we link the DB host to the DB service, right? So this is going to be deployed on this host on the port 5432. So this is going to be basically localhost 5432. But I don't have to type that in. I can just say DB, right? That's the alias. And there are volumes attached to this. So there's the web volume that I mentioned earlier. It's not by default. I've created it. Okay, when I booted up the DB accessory, I created the web volume. We can check that later. And of course, some secrets. And these are coming from, not from the Kamal secrets, but these are coming from the environment. So you have to define it here or here before you can use it here. Okay, accessories read from environment, environment reads from secrets. There we go. Same for Redis. Nothing different about it. Okay, so let's do a quick recap. So we named our service. We added the image name. So this is how we're going to upload it. We're going to upload it under this name to Docker registry. And this is an array of our servers. Right now we just have one, but I can add more in the future. We want a proxy. If not, we can just disable this proxy. And of course, if we are using multiple servers, we are going to remove this section and we're going to terminate the SSL at our load balancer. Okay, so we're not going to have a proxy in that case. We're just going to remove that section. This is the registry. Where do we want our images to be uploaded? How do we want to build them? What is the environment defined, the SSH user, and all of the accessories that our application depends on, like the database and the cache. Okay, last thing that I want to show you is the secrets. And this is a cool one because the secrets do not define any secrets. And this file is also being pushed to the repository. It is also Git tracked. And this is how it looks like. Okay, it's literally a way for you to not, of course, define the environment variables, but not assign the values to them, but orchestrate them in some way. Okay, so for example, in this case, I have the first one is going to be a 1Password account. And I'm just echoing whatever 1Password account is set to. And I'm assigning that to the 1Password account value. So these are shell commands. Okay, so we can do this, CLI commands, get the value, and then set the value to the environment variable. That means we can do something like this. We might have a text file so that we can do cat and then output the contents of the text file and store that into the app key value, right? We can do that, or even better, we can use the Kamal Secrets helpers to actually fetch the secrets from using an adapter. In this case, I'm using the 1Password adapter. So I have a 1Password account and I have all of my environment variables and secrets saved to that 1Password account. And I can share that 1Password account with my whole team so that we can all have all of these environment variables. I don't have to send them, the secrets via Slack or Discord or email or whatever we're using for communication. I can just add them to the 1Password account and all of them are going to have access to the secrets. That's really nifty. And Kamal has the adapter for 1Password and also for LastPass and Bitwarden and AWS Secrets Manager. I guess that was the name, and a whole bunch of other adapters. You can check them out here. If you go to configuration, if you go to commands and then secrets and scroll down, you're going to see, 1Password, LastPass, Bitwarden, the Bitwarden Secrets Manager, if you're using that one, the AWS Secrets Manager, Doppler, GCP Secret Manager. I don't know, too many of them. So you can check out the whole list here, but I'm using 1Password, okay? And I'm gonna show you how I have my 1Password set up and how I am pulling all of these secrets. So I'm gonna get my 1Password and I'm gonna add it side by side so that we can look at it. Here's my 1Password. Here's the Kamal. In this case, it's a collection, but what's important is that I have a Kamal vault in 1Password. And I have 3 items: production Postgres, which has these values, app key, which is some key inside, and this is basically for Laravel. Doesn't matter, it's just a base64 random generated string. And we also have the Docker registry, and I'm not going to show you this one because this is my actual credential to my Docker account. But I put all of these into the Kamal vault, and now it's time to pull them out. So I'm going to start with the DB secrets. The way that I approach things is I'm creating like one main item collection, and then I am extracting from that location. And I think that's the recommended way by Kamal as well, because there are secrets fetch command, which pulls all of these, or the ones that we define. And then there's the extract, which are going to extract from the value that we pulled them from. So let's see. Kamal Secrets fetch, adapter 1Password. The account is the one that I set the, as an environment variable locally. I'm not going to show you that, but that's the 1Password account. And then and now we define where our secret is. So I'm going to go until the end of the string and say from Kamal, the name of the vault. There we go. / production Postgres. So we are in this item, the production Postgres, and we are going to extract the database field, which is app, the username field, which is Postgres, and the credential field, which I think is Postgres as well. Doesn't matter. Yeah, we are going to extract these 3. Bear in mind, do not use passwords. In this case, use credential. I don't know what is it. I've been running into issues. Don't use lowercase passwords. All of the examples on Kamal's website use uppercase with underscores notation. Was this the screaming snake or something like that? So they all use this, maybe because that's the way that we're supposed to. I found that I can use this. I should just don't use the passwords lowercase word. So it's going to be credential, right? but this works. That's how we are pulling or fetching these three values. If we say type and server and port, I'm just gonna get them there. Doesn't matter, right? This is how we pull these three. And now we are extracting them over here. We are extracting them one by one. So Postgres_DB is going to be Kamal Secrets extract database. That is the name of the value from DB secrets, which is the fetch results. Same for the user, same for the password. Great. And now I'm just double defining these because that's how my setup is configured. I need both Postgres_DB and DB_database. Yeah, whatever. It's just two environment variables with the same value. So same goes for the Kamal registry secrets. It's just going to be a different item in this case. So it's going to be well, production Postgres is one thing, Docker registry is another thing, and app key is the third thing. And these are the three items that I have here. I kind of mixed those up, so forgive me about that, but doesn't matter, right? First you fetch and then you extract. And this is how Kamal can safely obtain these secrets and let you just upload them to, not just use them to upload and do its job, okay? This uses a CLI tool because it's the 1Password adapter. There is a OP tool by 1Password that you need to install. So if you can actually use this in CI/CD pipelines. You just need to have the OP, the 1Password CLI installed and set up in your CI/CD pipeline, and it's gonna work just the same. Okay, so let's actually take this for a spin. I'm gonna go here and I'm going to run, because I have a fresh server without even Docker installed, I need to provision it. And in order to do that, I need to run Kamal setup. So when I run Kamal setup, it's going to install Docker on all the servers, and we just have the one server. We added the IP address at the top of the file. If it has permissions, and if it's not already installed, it's going to boot all the accessories. That means DB and Redis, and it's going to deploy the app or run Kamal deploy for us. Okay, so when I run Kamal setup, it's just like the whole thing is going to be unleashed. Okay, so let's actually try that. Kamal setup. All right, let's see. So it's going to go into our IP address server here, ensure the Docker is installed. First, it acquires a deploy log, makes sure that Docker is installed. So now it's going to install Docker on the server. And let's see. It might run into some permission issues, and I'll show you how we can fix them. But there we go. First thing that happens. Tmux asks to get CLI access to 1Password, and this is how Kamal uses the 1Password adapter. It's literally asking the application to get those secrets. So I'm just gonna hit authorize. And let's see. Okay, now we can see that we are building the Docker image. So these are all logs from my Docker image. We can see inertia and Laravel is here, and Ziggy, and all of the dependencies. So yeah, this is going to take it's going to take a minute. There we go. We have the static assets. Okay, and now it even pushed it's starting to push the image to the Docker registry. There we go, writing layer, exporting cache to registry. Yeah, it built the image, and now it's uploading it to the Docker container registry. And once this is done, it's just going to go in and pull the image from the server. Okay, there we go. What does it say? Exception while executing on host this. Permission denied while trying to connect to the Docker daemon socket. There we go. So this is a permission issue, and we can solve this very easy. Let me just make some room, and then we'll solve this. Okay, so let's go back to our server. There we go. Now, because there's a group, a user group that Kamal is using under the name of Docker, and that doesn't exist. So we want to create that and add our current user to that group. So the way we do that is by using sudo usermod -ag docker and then the $user. There we go. Now, in order to confirm, we should just exit SSH back, and let's see if we have access to Docker. Docker is installed. It's just that Lazar-Kamal could not access it. So Docker v, there we go. Docker version 28.3.2. If I do Docker ps, we can see output. All right, so I can go back now and actually rerun Kamal setup. Not necessarily, but I can, or I can just do Kamal deploy because I already have Docker on my server. For good measure, I'm just going to run setup again. But this time it's going to be much faster because we're not going to be rebuilding the whole image. And also Docker is already installed. Okay, so now it's starting the container with the latest version. It's pruning the old containers, and there we go, releasing the deploy lock. And it's done in 92.7 seconds. That was fast. I already have Cloudflare pointing to 91.99, so that's where my DNS setup is. So if I refresh, we should see something here. Should not see this site can't be reached, but we should actually see something. All right, a small issue. I made a mistake earlier, so I got stuck on the SSL issue, but because I'm using Cloudflare and I was handling SSL on Cloudflare, I got in a loop, I got stuck, so the request wasn't going and reaching my server. But the way that I fixed it is that I just disabled Kamal's SSL. And this is exactly what it says. Like if you're using Cloudflare, set the encryption mode to full to enable CF2 app encryption and disable SSL and terminate SSL at the load balancer, or in this case, it's going to be Cloudflare. Just keep it at false. And if you're using Cloudflare, do not set the records to DNS only, but set it to proxy, and make sure that you set the encryption mode to full or flexible. I think in my case it's flexible, but there we go. We deployed the application. It's up. Woo! We can give ourselves a pat on our back because we are done, or are we? We got everything right set up for initial deployment. So we got the Docker image. We deployed it on our server. The site is live. We can see it. We can interact with it. We can go create accounts, register. It has a DB. Let me actually make a quick user here. Of course, password is going to be password because that's the perfect testing passwords. And there we go. Yeah, we are in the Laravel starter kit. We are logged in. We can log out and try to log in back so we can demonstrate that we have a database working. So I'm going to log in with a different password, and it should say, yeah, these credentials do not match, but I'm actually going to make it right now. Password, try to log in. There we go. Okay, so it does have a database, right? Cool. But we build our apps and then we evolve them, right? We need to deploy changes. So let's like make some changes here. Let's get some updates up, as it says, and see how that's working. So I'm just going to go into welcome.tsx. Let's get some updates up. I'm just going to say, okay, we got some updates, right? So we're going to make some changes. We're going to make some updates. And I'm just going to do not Docker, but Kamal deploy. Okay, so now it's going to be set up because we've already provisioned the server. We're just going to do a deploy. And in this case, it's going to rebuild our image, only the part that is changed, the layer that is changed, so not all of them, and redeploy it to the server. And we still get to keep the user that we created because it's not going to touch the database. It's only going to update the application. All right, so let's see how long that takes. And Then after this one, I'm going to show you how we can roll back to previous versions in case we push a bad commit or a bad update. So let's give this a minute and we'll do that. All right, so that took 96 seconds. Great. Let's go back to the browser, hit refresh. There we go. Okay, we got some updates. Yeah, Kamal deploy just brings all of those changes to all of your servers, and that's how you deploy to all of these that we mentioned before. Not by one, but you just run Kamal deploy. All right, let's actually go to and check out how we can roll back a faulty deployment so that we can, fix it without our users struggling to use the application. And in order to roll back, we're going to use the rollback command, but the rollback command needs a container name. So in order to figure out what is the container name, we're going to do Kamal app containers. And this is going to give us, as we can see, this is going to give us 3 containers. And these are the previous versions. Okay, so about a minute ago is the one that we pushed. And then 6 minutes ago, there's another one 12 minutes ago. So this is the previous one. So exited about a minute ago. And then this one got created. So this is the one that was created. So we need to grab this part of the application, my web app. We don't need that, just that part. And we can say Kamal rollback and then just paste the ID. Okay, so now it's going to go back to all of the servers and it's going to swap out the containers. It's going to stop the latest running one, the faulty running one, and it's going to reboot the one from before because we are rolling back to that one. And see, it's just like 15.8 seconds. If we refresh, it's not going to be, okay, we got some updates, but it's going to be, okay, I believe we made a mistake. I think we copied the wrong ID. So let's do Kamal rollback and then try the actual or like try this one. Maybe this one will work just fine. The one other issue or tip that I can give you right now is to look at the name. So these are uncommitted and then something next to it. Kamal is relying on the git commit in order to come up with these names. And because I'm just like changing stuff without even committing, that's why I have these long IDs and it's unreadable in my terminal. So do commit. Okay, push commits. In actual real life, you are gonna do that anyways. But just so you know, it's not gonna be like when you're actually working on a serious application with actual users and not just some demo application. So I rolled back to that other one. Let's see if that actually works. Okay, there we go. Let's get some updates up. So we're back from we got some updates or whatever. Yeah, rollbacks are fast. It's like 15.7 seconds for a rollback. That is, it's like perfect. Like pair it up with something like Sentry. You get an alert that you have a crash, a serious issue, and a lot of users are experiencing that issue. You immediately pop your terminal and you do Kamal app containers to look at these containers first. And then you do Kamal rollback with your previous ID to roll back to, where the bug didn't exist. So there we go. This was a pretty hefty one. If you have any questions, I mentioned before, and I'm not going to mention it again, go to creatures.sh and just join. It's my Discord server. There's a lot of people in there, and you can ask questions regarding Kamal or anything that you are dealing with. So I hope you like this video. This was a fun one. It does give you a lot of powers. I'm talking about Kamal. It does give you a lot of powers. You can basically follow this engine, just buy new servers, do some monitoring, like immediately look if there are add the limits these servers, like buy new servers, and then just use Kamal to provision and deploy your application to them. So yeah, 2 or 3 commands are important. Kamal setup to provision the server, Kamal deploy to push updates, and then Kamal rollback to fix your mistakes. So yeah, again, thanks for watching. Don't forget to subscribe, share this video with your team, and I'm gonna see you in the next one. All right, take care.